A very good morning to all of you. Please confirm if I'm audible. All right. All of you, please confirm. Voice is fine. Voice and audio. Please check the. Just a minute. All right. So, my dear, yesterday we were solving time and distance problems. So, this problem we have solved with the proportionality concept. Okay, proportionality. Proportionality normally we apply wherever something is constant. If something is not constant, there is no concept of proportionality which can be applied. So three parameters are there. So three situations arise. That means in some situations you will observe that distance is constant. In some situations you will observe that time is constant. And in some situations you will observe that speed is constant. Based on what is constant and what is not, we have to apply the proportionality. But it's very simple to think more distance, more speed, more distance, less speed, less distance. So proportional. If speed is more, time will be less. If speed is less, time will be more. So inversely proportional. And distance and time, more distance will take more time, less distance will take less time. So again, directly proportional. Now, these proportionalities we have to apply considering the question that what is constant in the question. We have to see that. Other than the proportionality, there is one more thing we will apply. Okay. So let's see one by one. So one is the proportionality. For proportionality, one case I'm taking. Distance is constant. If distance is constant, then speed and time are inversely related. Inversely. So inversely, how you will write is write S by S and write T by T. But since it is inverse relation, write opposite number. So write 1 and 2 on the left side and write opposite 2 and 1 on the right side. So this is what we can apply if distance is constant. There is one more thing which we can apply. Carefully observe. I'm taking two situations, situation number one, situation number two. Distance is D. Speed is S1, S2. Time is T1, T2. I'm assuming speed S1 is more, so time T1 will be less because distance is constant. More speed, less time, less speed, more time. So how these values are related, carefully observe. There is one formula which you have to memorize. Distance equal to T2 minus T1, S1 cross S2 by S1 minus S2. All right, this is your formula which you can apply to calculate the distance. If you carefully observe, distance is not there. In this relation, distance is not present. So this relation is important when we have to find S1, S2, T1 or T2. But if we have to find the distance, then this formula is more useful 90% of the times. 90%. So First, carefully answer. Is this formula a little bit bigger or not? Big in the size? Yes. A little bit bigger it is? Yes. Okay. I want to decrease the size of this. Okay. I want to decrease the size. I am not changing the formula. I want to decrease the size. You have to tell whether it is understandable or not. Distance D equal to T2 and T1. Both are timing. So write T. And it is difference. So write T minus. Are you able to understand this T minus is T2 minus T1? Are you able to understand? I want to make it short, nothing else. Okay, S1, S2, both are speeds. Okay, so write S. And it is product of speed, product of speed. So write a cross sign. Are you able to understand that S cross is the short form of S1 and S2? Able to understand? Yes. Similarly, this also is a speed and we are taking the difference. So write speed for S and minus for difference. So some notations, notation means representation. Some representation I have taken to create short form of these three, 1, 2 and 3. Short form is this. The meaning must be clear. Okay. All of you clear with this? So this is the formula we have to apply. You can, let me write this way also. T minus is difference of time. S cross is product of speed. And S minus is difference of speeds. Okay, so carefully observe. I have written this way also, I have written this way also so that you can relate what is the meaning. So T minus is difference of time, cross means product, S means speed, so product of speed and difference of speed is S minus. My dear, this formula is very simple to apply. Please remember that. Okay. Delta T, yes, that also you can take. Delta T, delta S, S cross. That also is fine. All right. Not everywhere I will apply this formula. Please remember that also. There is one more thing I want to tell you. In any situation, please be assured that you will have this relation always maintained. Distance equal to speed into time. Distance equal to speed into time. Okay, please be assured of this. All right. Now with this, we'll start certain questions. But before I start, answer one more thing. Okay, let's take the next question, then we'll start. First, try to break the problem into the way you have understood the theory. Try to break the problem. Virat traveled 75 kilometers in 7 hours. Okay, 75 kilometers in 7 hours. The complete 75 kilometers was not traveled at a constant speed. That is what they have mentioned. 75 kilometers, some distance he has traveled at 12 kmph and the rest at 10 kmph. So how far did he travel at the rate of 12 kmph? Some part at 12, some part at 10. So how much distance he has traveled at 12 kmph? That is the question. So carefully observe. Total distance is 75 kilometer. Total time taken is 7 hours. But some part of this is traveled at different speed. Some part traveled at different speed. Some part, let's suppose D. Suppose D, one part I am taking D. D is traveled at, let's say, 12 kmph. Okay, so carefully answer. If one part is D, the other part will be how much? Other part will be how much? Total 75. One part is D. So other part will be? My dear, D minus 75 is right if D is total value. D is not total. Total is 75. So total minus first part will give you the second part. So total minus D will be the second part. 75 minus D. Okay, this part is traveled at 10 kmph. All right. Now, I don't know why the student fear to apply this. My dear, distance is unknown. I know this. Here also, distance is unknown. But even if distance is unknown, time T1, T2, suppose I'm saying. So time, can you write as D by 12? Can you write or not? D by 12. Distance upon speed. Yes or not? So don't think always. The student, what they think is, if I know the value, I will write this. My dear, even if you don't know the value, then also you can write. Nobody can stop you writing this because it is valid relation. So please make a habit of writing the formulas even if you don't know the values. Similarly, here also I can say distance is 75 minus D divided by 10. Until now, anything doubtful, please carefully answer. Okay, what should I do next? Distance done, speed done, time done. What next? What is missing? I want to create one equation. What should I do? What should I do? Okay, carefully observe which value we have not used. Which value has not been used? Speed. Speed has been used. Distance upon speed is time. What value has not been used? Explain both as equal to D. Okay. If you add these values, it will become 75. So it will come out to be 75 equal to 75. So don't say that. We have used 75 already. If I say D1, D2, then D1 plus D2, 75, you can write. Distance equal to speed into time, we have already written. Distance equal to speed into time. My dear, T1 plus T2, carefully answer. T1 plus T2, is it not equal to 7 hours? Carefully answer. T1 plus T2. So this is what you have to write. So try to understand that how the equation has to be created. This is not the only way the equation can be created, but yes, this is one way. So T1 plus T2 is 7 hours. All right, now answer. T1 value as per us is D by 12. The second value is 75 minus D by 12. Do it very fast, these type of calculations. So 60, 12 into 5, so 5D, 10 into 6, so 450, 10 into 6, so 75 into 150, 450 minus 6D equal to 7. How much D will come? Please answer. Cross multiply. 30. Now check please. Is 30 is your answer? If 30 is your answer, is it? The question says how much distance he has traveled at a speed of 12 kmph. So is the distance D the answer? So yes, it is the answer. Distance D equal to 30. And what is the meaning of 30? 30 kilometers he has traveled at 12 kmph. So 30A option is correct. So understood all of you? Please confirm this. Just a minute. Okay, carefully answer. 75 minus 30 in that case. Sakit. I'm asking you certain questions under certain conditions. So carefully you have to answer. I'm assuming that you all live in a PG and you all leave for the center. Suppose it is offline class. So you all leave at 9 o'clock, or let's say for simplicity, 8:30. Okay. Assuming 9 is the reporting time for the class. At 9, the class will start. You leave every day, you leave at 8:30 sharp. No change. Now answer one by one. On Monday, you are reaching 15 minutes late to the class on Monday. Okay, so analyze please. On Tuesday, you are reaching 15 minutes early to the class. 15 minutes late on one day, 15 minutes early on the second day. So how much is the time difference of Monday and Tuesday? From your PG to your center. How much is the time difference you have taken? 30. Why not 15 minus 15? Why 30 minutes? All of you, please check this. Is it 30 minutes, the time difference? So what I'm saying is 9 is the reporting time. I'm saying Monday, you are 15 minutes late. Tuesday, you are 15 minutes early to the class. So I'm saying the time taken on Monday to reach from PG to center, and T2, the time taken from PG to the KodNest center. How much is the difference of these two values? This is what I'm asking. 0. So that means you are saying you have taken the same time from your PG to the center. Then how come one day you are late, you are taking same time, you are leaving the PG at the same time. So why not? It is 15 minutes late, 15 minutes late. Because if you are saying 0, that means equal. So is 0 correct? I'm not saying 15 minutes you are taking. I'm not saying that. 15 minutes late you reach. 15 minutes early you reach. I'm not saying 15 minutes is the time. So now answer again. 8:45 on one day, yes. 9:15 on other day. So difference. So my dear, you are reaching at 9:15 on Monday. You are reaching at 8:45. How much time difference? You are leaving at the same time. So you can calculate the difference from here. So how much time difference? 30 minutes. Okay, one more question. Let's say Monday, you are 15 minutes late. Tuesday, you are 25 minutes late. Now answer. Hmm. 10 minutes. Okay, how come 10 minutes? So Monday you are reaching at 9:15 and Tuesday you are reaching at 9:25. So 9:25 and 9:15, the difference is how much? 10 minutes. So this is what will be given in the question. So from this given information, they will not give you this PG is there and reporting time is there. They will just say one day you are 15 minutes late, one day you are 15 minutes early. So obviously your speed will be different, obviously, that is for sure. But will the distance be different every day? Will the distance change from PG to office? No, distance will not change. So my dear, in these situations, distance will not change. Speed will be different, time will be different. And that's why someday you will be late, someday you will be early, someday you will be on time. So based on that, we have to calculate the time difference, which we have shown by T minus in the formula, which is this. This formula we will apply. So carefully understand, look at the formula once again. This is what we will apply in the next question. And otherwise, if we don't apply this, we will apply the proportionality also. Okay. Yes, distance must be same. All right. Carefully see the question. A man reaches his office. I'm writing the formula first. A man reaches his office 30 minutes late if the speed is 3 kmph. 30 minutes late, speed is 3 kmph. Okay, now think next day. Next day, he is reaching 40 minutes early and the speed is 4 kmph. So 30 minutes late on one day and 40 minutes early on the second day. How much is the time difference on Monday and Tuesday? How much? I told you this reporting time, leaving your PG time, that will not be given. Just think it this way. 9 is the reporting. So on one day he is reaching late, 30 minutes late, so 9:30. That is the first day. Second day he is reaching 40 minutes early. That means he is reaching at 8:20. So what is the difference of time? How much? The difference of time will be 70 minutes. Okay. So 70 minutes is the time difference. Time difference is 70 minutes. We will never write the time in minutes. We will always write in hours. 70 by 60 hours. So 70 by 60. Okay. Now I will always say, the question will not say Monday and Tuesday, but I will always say one case Monday, one case Tuesday, third one Wednesday, like that. I will say that. Okay, please answer. The speed of Monday, speed of Tuesday. What is the product of Monday and Tuesday speed? What is the product? How much is the product of the speed? 12. Don't say 12, just say sir 3 into 4. Okay, what is the difference of the speed on Monday and Tuesday? Difference of speed on Monday and Tuesday. Higher minus lower. 1. 4 minus 3. So 4 minus 3. This is how you have to just apply the formula. So understood or not? Carefully see please. Once, all of you. Time difference is 70 minutes because one day 40 minutes early. One day he is 30 minutes late. So time difference will be 70 minutes. So time difference is 70 by 60. Speed product is 3 kmph, 4 kmph. So product is 3 into 4 and difference is 4 minus 3. Now solving it, we will get very easily the answer. 12 into 5 is 60. 4 minus 3 is 1. 70 by 5 is 14 kilometers. So B option becomes correct this way. So carefully observe. Anything doubtful? So to calculate the distance, this is the best way. Okay, best way. Now, I will give you one more question. Please try it. Not everywhere the language will be same. Please remember to apply this. The only condition is distance is constant and somewhere they are talking about T minus. Then you will apply this. Okay. All right. Chennai to Pondicherry, one person traveling on cycle. Another person travels the same distance. That means Chennai to Pondicherry again at the speed of 30 kmph and reaches 30 minutes earlier. 30 minutes earlier, that means 30 minutes earlier than the first person. So how much is the time difference? How much? Obviously, one person is reaching 30 minutes earlier. That means 30 minutes is the time difference, right? So 30 minutes is the T minus value. Distance is obviously constant. T minus is 30 minutes. Okay, so D equals to T minus S cross by S minus. Time difference is 30 minutes, but don't write 30, write 30 by 60 hours. You can write half also if you want. The speed. One person's speed is 7.5. Don't write 7.5, write 15 by 2. And one person's speed is 30 kmph. 30 kmph. Divided by, okay, divided by the speed difference. The speed difference will be 30 minus 7.5. 30 minus 7.5 will be 22.5. Okay. Now try this, please. How much will it come out? 22.5 you can write as 45 by 2 also. Okay. 45 by 2. 5 kilometers. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . So this is half. Now this is 15. My dear, this is 15 by 2, 7.5. 7.5 into 3. 3 into 2, 6. 6 into 5, 30. So 5. So A option, 5 kilometers I will get. Okay. If there is anything confusing with 22.5, because difference is coming out to be decimal, you can write 22.5 as 45 by 2 also for simplification. So carefully see please. Anything so far doubtful? All right. So next question. 15.2, 7.5 is the speed. So I have written 7.5 as 15 by 2. Okay. All right. 35 kmph. Okay, let's see. So first understand how many days are given here, how many situations, that many days we will be thinking. So how many days we have to think, or how many situations are there? Two situations. Okay. A person traveled from his house to office 30 kmph and he was late 5 minutes. First situation. If he increases his speed by 10 kmph, increases the speed by 10 kmph. Okay. In that case, he would be early to the office. Okay. Second situation. Third situation is the question. Because question is not direct. Question is not like what is the distance, what is the speed, what is the time. It's not like that. The question is what should be the speed so that he reaches office on time. So third situation. Three situations are there. Okay. So carefully understand. Distance equal to T minus S cross by S minus. We are taking the first and second situation. Carefully answer. First day, he was 5 minutes late to the office, 5 minutes late on Monday. Tuesday, he was 10 minutes early, sorry, 15 minutes early to the office. So 5 minutes late, 15 minutes early. What is the time difference? Time difference is 20 minutes. Okay. So time difference in this case is 20 minutes. That means 20 by 60 or 1 by 3. Okay. So T minus value is 1 by 3. Product of speed. Product of speed. Don't say 30 into 10. Don't say that. My dear, speed is not 10. Speed is increasing by 10. So previously it was 30. So now it will be 30 plus 10. So 30 into 40. Okay. So 30 into 40 is the speed product. And 40 minus 30 will be the difference. Anything doubtful so far? Please answer. So far. Okay. So solve this. This is 10. 10 will cancel out 0. Now 30 into 4, 120. 120 by 3 is 40. So 40 kilometers I will get as the distance. Okay. Now I have to take third situation because third situation they are asking something. Okay. And I am taking either first or second I can take. Suppose I am taking first. In third situation, he is on time. On time. In first situation, he is 5 minutes late. 5 minutes late. Okay. I can again apply the same formula for these two situations. I can again apply. So let's see if I apply what happens. Distance equal to T minus S cross by S minus. Distance we have calculated 40. Do you know the time difference? Carefully observe the two situations. Can you tell what is the time difference? 5 minutes. Okay, 5 minutes. So 5 by 60 hours. Okay, can you tell what is the product of speed? Can you tell? What is the product of speed? Can you tell? No, you will say, sir, we don't know. Sir, what is the speed in this case? I don't know. But yes, sir, this speed is how much? 30 kmph. So I can write 30 into S. All right, just answer one thing. Which speed will be greater? Which speed will be greater? S1 or S3? S1 or S3? My dear, here he is late. Here he is on time. So if you compare, he is reaching early in the third situation as compared to first. Here he is late. Here he is not late. He is early as compared to late. So this speed will be more, this speed will be less. So more value minus less value. Okay, now just simplify this. 30 into 2. So 30 into 2 will give you 60. Now 5 into 8 will give you 40. 8 into 2 is 16. 16 into s minus 30 equals to s. Now please solve this. Yes, S3 is more. Solving this, what you will get? 32. 16 into S minus 16 into 30. Keep it as it is, equal to S. This S will go there and 16 into 30 will go there. So I will get 15S equal to 16 into 30. Now 15 will cancel out 30, so 32. So 32 is the speed I will get, 32 kmph. Okay. So 2 times we will have to apply the formula because we don't have 2 situations. We have 3 situations. So one formula for first and second and one formula for first and third. This is what we have to do. So carefully observe once again. Is this clear or not? All of you, see this please. All right. Similar question. Again, 3 situations we have. Again, Albert is thinking to go to a destination point A. So 3 times he is thinking. The first thinking is, if I travel at 10 kmph, then what happens? The second thinking is, if I travel at 15 kmph, then what happens? And third one is, he is thinking now, I want to reach at 1 p.m. So what should be the speed? So this is what he's thinking. If I travel at 10 kmph, I will reach the destination at 2 p.m. If I travel at 15 kmph, I will reach at 12 noon. So what should be my speed if I want to reach at 1 p.m.? This is what he is thinking. Now carefully answer. Just for clarity, I'm writing. Distance is d. Speed is 10 kmph in the first case. In the second case, it is 15 kmph. And third case, it is unknown. Okay, we don't know. In first case, 2 p.m. and 12 noon. Second one, 2 p.m. 12 noon, and here it is 1 p.m. This is the reaching time. Okay, carefully answer. If I take the first and second situation, please carefully answer. Time difference, can you tell? How much is t minus value? Please remember this. The language will not always be late and early. Not always. So time difference, how much? 1 hour. He is reaching at 2 p.m. Here he is reaching at 12 noon. So time difference is the difference of the arrival time. Okay. So he will arrive at 2 p.m. He will arrive at 12 noon. So the difference is 2 hours. So carefully observe, please. I am writing for the first and second situation. I am writing distance equal to t minus s cross by s minus. Okay. T minus you are telling, so t minus is 2 hours. Okay, speed. Product of speed is 15 into 10. 15 into 10 is the product. Don't write 150, write 15 into 10. And S minus. So 15 minus 10. 15 minus 10, directly write 5, but I'm writing 15 minus 10. Now solve it. Solving this, what you will get, please answer. How much you will get? Distance is 30, not 30. 5, 3, 3 into 10, 30 into 2, 60. 60 you will get. 60 kilometers. My dear, everywhere you know the speed in the first and second case. Now you know the distance also. Distance is 60, distance is 60. So carefully answer. In the first case, how much time is taken? In the second case, how much time is taken? Answer that. How much? In the first case and second case, how much time is taken in the first and second case? Or don't say T minus. T minus I will apply later. I'm telling you other approach. Okay. You will say, sir, T1 equals to distance divided by speed. Speed is 10. So 60 by 10. That means 6 hours. In the second case, again, you will say, sir, time equals to distance divided by speed. Distance is 60, sir. Speed is 15. 60 by 15, that means 4. Right? Okay. So time difference, here also you can check. It is 2 hours. Whether you calculate from T1 and T2 or whether you calculate from the reaching time, it will be same. Now just answer very carefully. You want to go somewhere. If you take 6 hours, you will reach at 2 p.m. If you take 6 hours. If you take 4 hours, you will reach at 12 noon. Let me take just one case. If you take 6 hours to travel, you will reach the destination at 2 p.m. If you take 6 hours, if you want to reach at 1 p.m., how much time you should take? Please answer. 6 hours, 2 p.m. you will reach. How much time you should take? If you want to reach at 1 p.m., not 2 p.m.? 7 hours. If you take 7 hours, it will be 3 p.m., not 2 p.m. If you take 6 hours, 2 p.m. So 7 hours, 3 p.m. 8 hours, 4 p.m. So how much? 5 hours. Similarly, you can think from here also. If you take 4 hours, you will reach at 12 noon. I don't want to reach at 12 noon. I want to reach at 1 p.m. So how much time should I take? 4 plus 1 or 4 minus 1? 5 hours. So both ways, whether you calculate from this or this, it will come out to be same. I'm saying is, think it this way. I reach at 2 p.m. So if I take 5 hours, I'll reach at 1 p.m. Yes or not? Carefully answer. Very carefully. Yes. Carefully see. Anything which seems logically wrong with this? No? Okay. So for the third situation, they are asking you the speed. My dear, speed equals to distance upon time. I know the distance 60. I know the time 5. So distance upon time 60 divided by 5. That means 12. So 12 kmph must be the speed of the person. If he travels at 12 kmph, he will reach at 1 p.m. to the destination. So carefully analyze that where what relation have been used. Carefully see. All right. Now, next question. Okay. Maria drove to the mountains last weekend. There was heavy traffic on the way there, and the trip took 9 hours while going. Okay. When Maria drove back home, there was no traffic. So in that case, the speed will be more, time taken will be less. So while going 9 hours, while returning 4 hours. Okay. If her average rate was 40 miles per hour faster on the trip home means returning back. So while returning back, the speed was 40 miles faster as compared to the previous, while going. So how far are the mountains? That is the question. So carefully observe. While going, distance is d. While returning also, distance is d. While going, you are taking 9 hours. While returning, you are taking 4 hours. While going, your speed is, I don't know, S, suppose. While returning, your speed is S plus 40. Are you able to understand this? Just answer that. Carefully tell. Are you able to understand? Yes. Now, my dear, there are various ways. Can you tell distance is constant? Yes. Distance constant. Do you know what is T minus? Two situations are there, going and return. Can you tell what is T minus? Difference of time? 5 hours. So we can apply this formula as well. Distance equal to T minus S cross by S minus. Okay, distance. Distance I don't know. Time difference is 9 minus 4, 5 hours. Okay, T minus is 5 hours. Okay, S cross. S cross, let me write. So speed is S. One speed is S plus 40. Speed difference will be S plus 40 minus S. So let me again simplify this. S plus 40 minus S, sorry, S plus 40 minus S is the speed difference. It will come out to be 40. Can you solve it? Answer, please. Can you solve it? Right now, in this current situation, the formula, carefully observe, I'm asking, can you solve it? No. Okay. So that means formula right now in this current form is useless. So we have to do something, otherwise it's useless. So what else can we do so that we can get something out of this? What else can we do? Answer that, please. We have applied the formula, but it came out to be useless because I don't know what is S. So how can I calculate distance? Or if I don't know distance, how can I calculate speed? Any one thing I should have. Correct, Sakib. So my dear, just carefully answer. Distance, you write it in terms of a speed. Can you write this or not? Distance equal to speed into time. Can you write this or not? Carefully answer. Yes, see please. Here also you can write. Here also you can write. There also you can write. Any one place you write it for first or second situation. So distance equal to speed into time. S into 9. So 9s you put it there. Then you can solve. 9s equal to 5 into S plus 40 divided by 40. Now solve it, please. What answer you will get? S will cancel out. Solve it. 5 into 8. 8, 9, 72. Okay. 72. 5S. Thirty-two. 32 S value you are saying? Okay. Distance will be how much then? Distance will be how much? 32 into 9. 32 into 9, how much? 32 into 9 is 288. So this way 288 will come out. Okay. So let me write this. So 5 into 1, 5 into 8. So 9, 8, 72. This is, okay, this is cancelled. S plus 40. So S equal to 32. Okay, 32. So that means distance equal to 9S. So 32 into 9. That means 288. And because the question is in miles per hour, so it will come out to be in miles. This is the first way. Personally, I will say this is not the good way. For the first time, the same formula, I'm saying it is useless. It is not better. It is okay, but it is not a very good approach. Why it is not good approach? Understand, please. Because I know that where it is good, where it is bad, you also must know. So, my dear, you don't know the speeds. You don't know the speeds and speed product we are having. So, you don't know it. That's why it will become s square. If you multiply s square, it will become. So, wherever this situation arises, where you don't know what is the speed, don't apply the formula. So, what is better way? Please understand carefully. It all depends on what is given to understand what is the better approach. Speed is not given, don't apply the formula. Do it this way. Anything wrong with this? This is distance in case 1, distance in case 2. Anything wrong? No. Okay. Can I write distance equal to speed into time? So speed into time. Can I write the second distance as speed into time? Into 4. Now solving this, what you will get? Solving this, what you will get? Speed. The same way the previous question, same way you will get here also. So 9 and this will be 5. So 5 and this 160 by 5. So 32. So solving this, you will get the speed as 32 kmph. So is it better or not? Carefully answer. Distance is speed into time. Here also distance, speed into time. Equate it. By equating this directly, you will get the speed as 32 kmph, and this gives you distance equal to speed into time. That means speed is s, time is 9. So 32 into 9. 288. So carefully understand. Is it clear or not? Observe please. Distance in case number 1. Divyashri. See the first column. Distance is d, time is 9, speed is s. So can I say distance equal to 9 into s? Can I say yes? Okay. Second column. Distance is d, time is 4, speed is s plus 40. So can I say distance equal to s plus 40 into 4? Yes. And both the distance are same, so you can equate it. All right. So this is also one way. If distance is same, calculate distance, equate it. Speed into time, equate it. If suppose speed is same, so distance upon time, equate it. That is also good. So it depends on what is constant. Whatever is constant, calculate for the first one, calculate for second one, equate it. So this is the best way to solve it. Let's see the next question. All right. Try to solve the problem. And think of the best way. So many things you have seen. Think of the best way. All right. So carefully understand the question. A train can travel 50% faster than a car. Speed is not given. 50% faster than a car. This is what is given. Both start from the same point A at the same time. Reach point B also at the same time. Okay, sorry. Reach point B 75 kilometer from A. So at the same time. Okay, start from the same point, same time. Reach the point B, same position, same time. So that means they are taking same time to reach. How come is it possible that train is faster than the car? Train is also reaching the point B and a car is also reaching the point B at the same time. How is it possible? Speed is not same. How come is it possible? Because of the stoppage. That is what they have mentioned. On the way, however, the train lost 12.5 minutes while stopping at the stations. So think it this way. Okay, car is taking time t. Train also is taking time t. This is point A. This is point B. Okay, both are taking same time, but same time they are taking because stoppage time of 12.5 minutes is included. Okay. So 12.5 minutes is the stoppage time. Then they will reach the point B at the same time. Okay. If I don't count this, then answer, who will reach first? If I don't take the stoppage time, suppose train is not stopping, who will reach first? Train. How many minutes before it will reach? 12.5 minutes. So can I say the train will now take t minus 12.5? Carefully answer, yes or not? If I don't take the stoppage time, yes? Okay. So now carefully see. If I write the formula, distance equal to t minus s cross by s minus. Distance is 75 kilometers. 75. How much is the difference of time taken by car and train? How much is the difference? How much? 12.5 minutes. Okay, 12.5 minutes. So 12.5 divided by 60 is the time difference. Okay. What is the product of a speed? Have they given the speed? No, they have not given the speed. So they have not given the speed. You tell me. They have given a relation. A relation also will be sufficient to answer. Who is faster? Who is slower? Just tell me that. 50% faster than a car. Train is 50% faster than a car. Okay. If suppose, carefully answer. If suppose I am saying car speed is 100 times of x. 100 times of x. What is the speed of the train? 100 times of x for the car. 50% faster. 50% faster means plus 50. So train speed will be 150x. Are you able to understand this? Carefully answer. 100x, 150x, because percentage is given. That's why I'm not taking x. I can take x also. If I take x, I will write 1.5x. If I take 100x, I will write 150x. So please put these values now. So 100x multiplied with 150x divided by the difference. The difference is 50x. Now please solve it. X will cancel. Please solve this. How much you will get? 12.5 into 2 is 25. Okay, it will not cancel out. So 12.5 into 2 will be 25. 25 into 3 will be 75. Okay, next 50. 50 into 3. Okay, 3 into 20. 20 into 5. Okay, 3 will cancel. So what is coming out? X. This is X and that is 2. So 2 equals to how much? 2 equals to, this is 5 into X. So X equal to 2 by 5. Right? 2 by 5. Please verify, is it correct or not? X equal to 2 by 5. Verify please. Is it right? 12.5 into 2 into 3. 50 into 3. 3 into 20. 20 into 5. 3 cancel, yes. Okay. So 2 by 5. I have to calculate the speed of the car. The speed of the car is 100x. So it implies the speed of the car equals to 100x equal to 100 into x value. X value is 2 by 5. So 5 into 20, 20 to 40. Okay. So 40. Somewhere we have done the mistake. 5, 20, 20 to 40. Somewhere there is a mistake. Are we missing something? Please check something we are doing a mistake. Let me see from here. On 3 got cancelled now. Just a minute. All right. So 12.5, 25, 25 into 3, 75. Okay. Then 50 into 3. Okay. Then 3 into 20. And 20 into 5. Okay. 3 is cancelled by this, not by this. Okay. So 6 by 5 I will get. Okay. 6 by 5. So 6 by 5, that means 20 into 6 I will get. So 120 kmph. All right. So again, in this question as well, what we have seen is that we have applied the same formula, but what we have seen is that time taken is 12.5 minute less if we don't take the stoppage time. So T minus value is not directly given, but indirectly it is given. So we have applied this formula and we have solved the question. So carefully see once. Is it clear? All right. Java and SQL recordings, you're not able to see. How you normally tell your problems? What is the portal? On the same portal, please generate one issue. Okay. A ticket will be generated for the same, and please send the screenshot as well. All right. I will assist you after the class. Okay. Just wait for a while. My dear, there are two objects. Okay. Distance is 75, distance is 75. Speed is not same, so time also is not same. But distance is constant. So carefully observe, distance is constant. So speed and time, how are they related? Please answer. How are they related? Speed and time. How are they related? Inversely. Okay. So inversely, that means car and train. So train and car. Able to understand this? Carefully answer. Yes. So speed and time are inversely related. That's why we have written this car and train, train and car, opposite. Okay. Speed of the car, do you know? We are taking 100x. Speed of the train will be how much? Speed of the train, how much? 150x. 50% faster, so 150x. Okay. This is train, timing of the train. I know the difference of timings, right? So one time you take it as t. I've taken the car timing as t. So this will come out to be t minus 12.5. My dear, it doesn't matter whether you take t and t minus 12.5. Just carefully answer once. How you take the variable relatively can be different for different persons. You have to tell whether there is something logically wrong with this. Who takes less time? Please answer that. Car or train? Who takes less time? Car. So it takes a time of t, I'm assuming. Okay, time taken by car equals to t. So time taken by train. My dear, train takes less time, not car. So time taken by train, take it as t because it is less. So I'm assuming it as t. Forget the previous solution. Okay. So time taken by train, I'm assuming as t. So time taken by car will be how much extra? Observe the question. How much extra it will be? Carefully see. Not twice of t. How come twice of t? T plus 12.5. T plus 12.5. Okay. So time taken by car will come out to be 12.5 minutes extra. Okay. So previously we have taken opposite. We have taken this as t and this as t minus 12.5. So previously it was t and t minus 12.5. Now it is t and t plus 12.5. So both ways it is right. Only the meaning has changed. Now t belongs to train. Previously t belonged to the car. Okay. Now we have to solve this. So 50 into 2, 50 into 3. So 2 by 3. All right. Now carefully observe please. Very simply we can calculate. Actually we have to calculate the speed, but we will calculate later. This will give you the time. Okay, this will give you the time. Carefully answer one thing. This is 2, this is 3. The difference is 1. Here the difference of denominator and numerator is 12.5. Difference is 1, difference is 12.5. Make it same. Difference is 1. To make it 12.5, you will have to multiply with 12.5. Now you can check the difference later, but yes, the difference will be same now. Okay, let me write this. 12.5 into 2 is 25, and this is 37.5. Carefully answer. What is the difference on the left side of numerator and denominator? Difference on the left side, how much? 12.5. Difference on the right side also 12.5. Yes or not? Numerator, denominator. So difference, make it same. You will get the direct answer. So direct answer will be t equals to 25. Because you can compare. You can compare it. Let me show this. Why I am saying this. 25 by 25, 12.5. 25 plus 12.5 is 37.5. T by t plus 12.5. Please compare the left and right side and answer what is the t value. Compare left and right side. What is the t value? 25. T value 25, t value 25, 12.5, 12.5. So comparison will give you the t value. This is one way. Other way is you just cross multiply. You will get your answer. This is second way. Okay. The second way is solving by the ratio. Okay. Solving, actually I'm thinking 2:3. This is what I'm thinking. So this will give you t equals to 25. All right. 25 minutes, please remember. All right. So speed of the car they are asking. Speed of the car. Okay. So distance 75 kilometers. Time is 25 minutes. So that means I can say 25 by 60 hours. So speed of the car will be distance divided by time. 75 divided by 25 divided by 60. How much it will come out? Please answer. How much this will come out? Sorry, this is the train speed. T value is the train time. So train speed you will get. How much this will come out? 180 it will come out. Okay, so this will come out to be 180 kmph. This is for the train because T value is for the train. So this is for the train. If I take the car, the car value is T plus 12.5. So T plus 12.5, let me write this. Time is T plus 12.5, that is 37.5 minutes. So speed will come out as 75 divided by 37.5. This is kilometer and this is minute. So this will give you 2 kilometers per minute. 2 kilometers in 1 minute. So how much kilometer in 1 hour? 2 kilometers per minute. So how many kilometers per hour? 60 times, because 60 minutes is 1 hour. So 2 into 60 kmph. Okay, this is for the car. Okay, this is for car because we have taken the time of the car. So now the speed is of the car. So this is doing by the proportionality. Okay, proportionality. This is the second way. So understood this or not? Please carefully see. Whichever seems to be better approach, you can take that. For me, I will say both approach are equally good. See, please. Because it is 2 kilometers per minute. Okay, it is not kilometer per hour. 2 kilometers in 1 minute. So you will travel every minute. You will travel 2 kilometers. So in 1 hour, which is 60 minutes, it will become 120 kilometers. So 120 kmph. All right. Try this question, please. By walking at 3/4 of his usual speed, a man reaches office 20 minutes later than the usual. Okay. Usual speed, that means the speed at which you travel daily. Okay. And actual speed is the speed which we have traveled today. So today I have traveled at not the usual speed, some different speed, and that is 3/4 of the usual. So think it this way. If usually I travel at 4 kmph, today I'm traveling at 3/4. If usual speed is 4, today my speed is 3/4 of 4, that is 3 kmph. This is the meaning. So now carefully answer. It is distance, it is a speed and time comparison. So distance is constant. You are traveling somewhere, the distance will be constant because it is office. Okay. Sorry. So distance is constant. So can I say, carefully answer, speed and time, can I say this or not? Yes. Speed and time are inversely proportional. So can I say or not? Yes. Okay. Now, why I'm not writing that formula distance equal to t minus s cross by s minus is, they are not asking us distance. Speed is not given. Speed is okay. 3 by 4 relation is given, but speed is not given. Relation is given. So don't apply. This is better. So S1 by S2. Carefully answer. First, you have to decide what is 1, what is 2. I'm assuming 1 is the usual speed case. The number 1, that means usual speed case. And number 2 is actual. Actual case, or suppose it is the case of today. Usually you travel at these values, but today you are traveling with these values. Case of today. Okay. Carefully answer. 3/4 of usual speed, that is your speed of today. Is it more or less than the usual speed? Is it more or less than the usual speed? Less. 3/4 is always 3/4 is less than 1, so less. It means less. Carefully tell. Second means speed of today. First means usual speed. First means usual speed. If usual speed I'm saying 4x, the speed of today will be how much? Usual speed, I'm saying it is 4x. So 3/4 of 4x, how much it will come out? 3x. So 3/4 of usual speed. Okay, so this will come out to be 4 by 3. All right, now go to the time. Usual speed is more. This speed is more. This speed is less. Which will take more time? The first one or second one? In which case you will take more time? Second case. Speed is less, time will be more. Okay, there it will be less time. Time is less, time is more. Okay, time is less in the first situation. So first situation you write as t. So we are taking t1 equal to t. So carefully answer. T2 equals to how much? Read the question and tell. T2 equals to how much? T plus 20. Okay, so T2 equals to T plus 20. Now solve it, please. So 40 and 3t plus 60, 4t plus 3t plus 3 into 20 is 60. So t value will come out as 60. But my dear, please remember, this is minutes. So this will also come out to be in minutes. Okay. So what is the usual time? Usual time means t. So usual time is 60 minutes. So we have applied the proportionality, carefully understood what 1 means, what 2 means. So 1 means usual speed case and 2 means the case of today. Okay. So with this, we have written the values as per the relations which is given in the question, and we have got the answer. Carefully see it once. Hmm. All right. My dear, these questions are very simple actually. Okay, very simple. Just if you remember one thing, that distance is constant. So whatever relation they have given 3 by 4, that is a speed ratio also, and that is time ratio also. Think it this way. What is 1 and 2? You can think later also. Speed is 1 and 2. So time you can say 1 and 2, just opposite you say 4 and 3. Speed is 3 and 4, directly take 3 and 4. So time will be just opposite because speed and time are opposite. Now, once you see these timings, will you say that one time is 20 minutes more than the usual? Will you say that? Is there a difference of 20 minutes? Just answer that. Is it there? 20 minutes difference with these values. Proportionality wise, these values are correct. But do we have a difference of 20 minutes? 20 minutes. Do we have? No, it is 4 minute, it is 3 minute. So it is not 20. So right now the difference is 1. Make it 20 minutes. To make it 20 minutes, multiply by 20. Okay. So now you are getting the timings as 80 minutes and 60 minutes. Now you have to tell the lesser value will be the usual time or higher value will be the usual time. You have to tell. Answer please. Higher value. My dear, usual speed is less or more? Usual speed is less or more? I'm saying you have written this 3 and 4, you have written opposite. We don't know what is 1. 1 is usual or actual, we don't know. 2 is usual or actual, we don't know. You have to analyze now. Question is nearly done, 99%. You just have to analyze. 1 or 2 is the answer. Okay, usual speed. You are walking at 3/4 of usual. That means your speed of today is less. Usual speed is more. So usual speed is more. Usual speed is more. Time will be less. So less time is this. So this is your usual time. Okay. This is usual speed because it is more. So this you have to understand later. First write the values, then see 1 is for usual or today. 2 is for usual or today. You think it later. This is the best way to solve it. Let's see the next question. Yeah, the next question, carefully see. I will solve it the same way. In covering a certain distance, the speed of A and B are in the ratio 3 and 4. A takes 30 minutes more than B to reach the destination. Okay. So speed, A and B. I'm talking about speed. 3 and 4. So time and time of A and time of B. My dear, this is speed ratio. It is not speed. It is a speed ratio. So speed ratio is this. So time ratio, don't see there, time ratio will be how much? Tell me ratio. It will be opposite or not? Because inverse relation. So can I say it will be 4:3? Yes or not? Yes. Okay. So A and B speed ratio they have given. Time ratio I can say just opposite. 4 and 3. Now I will check. I cannot say these are the right values. It is right now ratio. Ratio is not values. Ratio is ratio. Okay, please carefully read the question. What they are saying about time. So A takes 30 minutes more than B. Will you say A takes 30 minutes more than B? Will you say that with these values? Would you say that? With these values, A takes how many minutes more? With these values, how many minutes more A takes? 1 minute more. I don't want 1, I want 30. So multiply by 30. Now check please. Is now, with these values I am saying, is A taking 30 minutes more than B? Check please. Carefully check. Is A taking 30 minutes more than B? Check. 40 into 3, 120. 30 into 3, 30 into 3 is 90. 120, 90, 30 minutes difference. So question is done. Time taken by A to reach the destination is 4 into 30, that means 120, 2 hours. It is correct. So this is one more different way. This is also proportionality. Okay, this is also proportionality. Okay. So let me write this once. SA by SB equals to TB by TA. SA by SB you can write as 3 by 4 because they have given ratio. And then you can say the time, I'm telling you the proportionality. This is ratio, proportionality. So time taken by A is 30 minutes more. Okay, so this is T plus 30. You will solve this to get the T value, then T plus 30 will be your answer. Okay, so two ways I have told you, both are nearly same. This is less calculative, this is more calculative. Logic is nearly same in these two. So carefully observe once. 3:4 is the speed ratio. So 4:3 will be the time ratio, just opposite. Okay. Now, if I take 4 and 3, the difference is not 30. I want a difference of 30. So multiply by 30, you will get your answer. Okay. Now, next. If a person walks at 14 kmph instead of 10 kmph, he would have walked 20 kilometers more. Think it this way. If, my dear, if means imagination. Instead of, that means this 10 kmph is reality. If part is the imagination. So, what you are thinking is you are observing a man. The man is traveling at 10 kmph. Okay, 10 kmph. He traveled a certain distance in a certain time. You observed it. Okay, you are observing the person. He was traveling at 10 kmph. He traveled a certain distance, which is not given. For a certain time, you have observed. Now you are saying if this person travels at 14 kmph, then he can travel 20 kilometers more. Obviously, if you are comparing, if you are saying 20 kilometers more, so your intention must be this only, that he can travel with this speed 20 kilometers more in the same amount of time. So this is what is given in this question. Now, again, carefully see please. What is constant? Just answer that. What is constant? Time is constant. Okay, time is constant. Okay, time is constant. Distance is proportional to speed, yes or not? Because time is constant. Yes. So I will tell you the same proportionality two ways. One way is I will write it as a formula, and one way is I will solve it as a ratio. So carefully understand. Think it as case number one, case number two. Okay, distance is d. Let me first write the. Let me first write the speed. Speed is given, that's why. So speed in the first case 10 kmph, and speed in the second case is 14 kmph. Okay. Now don't think kmph. Think ratio. Speed S1 ratio S2 is 10 ratio 14. Okay. So can I say D1 ratio D2 also as 10 and 14? Because they are proportional. So speed ratio, distance ratio will be same. Yes or not? Carefully answer. Carefully. Okay. And now, carefully think. You know my habit. I don't usually write the ratio sign. So speed is 10, speed is 14. Distance 10, distance 14. There is some problem. Carefully observe the distance, what they have given. In second case, the distance should be 20 kilometers more. Will you say distance is 20 kilometers more than this? Will you say that? No. How much more it is? It is just plus 4. I don't want plus 4. I want plus 20. I want D and D plus 20, not 10 and 10 plus 4. I want D and D plus 20. So what should I multiply? What should I multiply? 5. Okay, multiply by 5. So multiply by 5, multiply by 5, multiply by 5. This is your distance. So distance 50, distance 70. Now distance, actual distance traveled by him. Actual is this or this? Please answer. First or second? What is actual? Not imagination. What is actual? What distance is actual? D or D plus 20? D is actual. My dear, if condition is this, if is not reality. Before if, the reality is there. This is not reality. If means this part is imagination. So this way D is correct. So D is your answer. All right. So this is solving by the ratio. If I solve it by the proportionality, again same. Just need to write the values, nothing else. So with proportionality, if I write the formula d1 by d2 equals to s1 by s2. d1 value is d, d2 value is d plus 20, s1 value is 10, s2 value is 14. Solving this, you will get the d value as 50. And that is your answer. So both ways it is correct. Both ways. All right. So see please. Multiply by 5 because values are not satisfying these this condition. It is not d and d plus 20. The difference must be 20, but with those values, the difference is 5. I've taken the values directly thinking as a ratio. I've taken the values directly thinking as a ratio. But I know ratio is not values. Ratio has to be modified, then it will give you the values. Ratio has to be multiplied, then it will give you the values. Okay. All right. So two ways, both are 90% similar, I will say. Okay, both are 90% similar. Now, one last question. Okay, two cars start from A and B. Okay, one car start from A, one car start from B. Okay, travel towards each other. Okay, 50 and 60 respectively. So 50 kmph and 60 kmph respectively. They start at the same time. Suppose they start at, let's say, 9 a.m. So both of them start at 9 a.m. Now they will meet some place they will meet, yes or not? Some place, sometime they will meet. Yes. Okay. So they are traveling in opposite directions. Somewhere they will meet. Let's say they are meeting at this place. This is point C. They traveled, I'm just saying 9. Suppose they meet at 11. Suppose. Now answer please. At C point, they will stop. What is constant for A and B? 9 they start, 11 they stop. The speed is 50 and 60. What is constant for A as well as B? Time is constant. The car A is traveling from 9 to 11. The car B also is traveling from 9 to 11. My dear, in meeting question, please remember, starting up to the meeting, time is constant for both the objects. Okay, so time is constant. But let me remove this. I cannot take these values. So just to make you understand, I have taken the values. So time is constant. So distance proportional to speed. Okay. Distance proportional to speed. All right. Let me solve it by the ratio. Okay. So SA, SB. Speed of A 50. Speed of B 60. Okay. So distance by A, distance by B. If I directly take the values, it is not correct. But I'm directly taking the values because they are proportional. And right now I'm just thinking ratio. Okay. I'm thinking ratio right now. But I usually don't write the ratio sign, you know. Okay. So it is right values 50 kmph, 60 kmph, but this is ratio. I have directly taken the values as it is 50, 50, 60, 60 because they are proportional. But right now it is ratio. Please remember that. Just answer carefully what they are telling about distance. The meeting, at the time of meeting, second car has traveled 120 kilometers more than the first. Are you observing that second car has traveled 120 more than the first? Is it right? Is it right? No. So please answer. How much more this second car has traveled? How much? How much more it has traveled? 10 more. I don't want 10. I want 120. What should I multiply? I don't want 10. I want 120. This plus 10, I want 120. What should I multiply? Multiply with 12. Okay. So multiply with 12. So this will give you 600 and this will give you 720. Now check please. Ratio part is done now. These are actual values I'm saying. So please confirm the second car has traveled 120 kilometers more than the first, yes or not? Yes. Second car has traveled 120 more than the first one. Yes. Okay. So question is done. Now we have to see what they are asking. So they are asking what is the distance between A and B. Okay. This car started from A. This car started from B. Will you say distance is 600? Please answer. A to B, will you say distance is 600? No. So what I'm saying is, please see, this 600 is the distance traveled by A. So A to C is the meeting point. C is the meeting point. And B to C, B has traveled. The car who has started from B has traveled from B to C. So one has traveled 600, one car has traveled 720, one car traveled 720, one traveled 600. Total distance will be 720 plus 600. So 1320 you will get. Okay. So distance A to B is 600 plus 720. Okay, 1320. So this is the best way to solve such questions. Please remember, something must be constant, then you can do this. If nothing is constant, you can do nothing. You will have to apply the very general formula, which is d1 by d2 equals to s1 into t1 divided by s2 into t2. Okay, so all of the questions which we have done today, anything so far doubtful, please confirm this. We are concluding the class with this question. See, please. Tomorrow we'll start with the crossing based question, which will be mostly based on trains, not mostly, based on trains only. Okay, attendance link. All right, so day before yesterday, I've shared a PDF. That PDF was a previous batch, that means June batch PDF. A little bit here and there difference might be there. That PDF had the solutions up to time and distance. Okay, not maybe complete, but yes, it had the solutions. I will share from this PDF. Okay. Okay, I will start sharing from this PDF. This solution and that solution will not match completely 100%. Okay, will not match completely 100%. So please remember that. Okay. All right. So we'll meet tomorrow, same timing. Tomorrow is Friday now. Yes. So we'll meet tomorrow, same timings, and we will conclude this topic tomorrow. Thank you. Mrityunjay, please be in the meeting. Just let me see if somebody is there.